Today's lesson is on annuities, methods of saving, and investment. So we need to go through some definitions first. First, a return is a percent increase on an investment. Next, we have annuity. An annuity is a sequence of equal payments that are made at equal time periods. For example, an annuity would be like an IRA or an individual retirement account. So to save for retirement, you might decide to put like $1,000 into an IRA each year until you retire. This series of equal payments at equal intervals is an example of an annuity because it's the exact same amount and the exact same time between each payment, and you're trying to save up. So that would be an example of an annuity. The value of annuity is the sum of all deposits plus any interest paid during that time. So we have a new formula for the value of an annuity. This is where we're putting in money every equal interval. So there's your formula. As a reminder, the A is the future value. The P, that's the present value, or the recurring deposits or periodic deposits that you're going to use. The R is the rate, and notice that pops up twice. The T is the time, the number in years that you're going to be accumulating this. And then the N is the number of interest payments in 1 year. So if you're going to just do it once a year, then N would be 1. If you're going to do it like every month, then N would be 12. So every time that you put in values, okay? Now, one other thing we need to talk about is the interest on an annuity. So the interest equals the value of an IRA minus the total deposits. So once we figure out what the A future value is, and then you subtract all the total deposits off, then you can find out just what the interest is. Now the total deposits would be P, the thing that you're depositing each periodic period, times the number of payments that you do in a year times the number of years, and that will get you the total amount of deposits. If you subtract that off the value of the IRA, which is the A, then you'll get the interest. So this right here, interest equals the value of the IRA, that's A, minus P and T will get you just the interest if you're looking for just the interest. Our first example says at age 30, to save for retirement, you deposit $100 at the end of each month into an IRA that pays 9.5% compounded monthly. How much will you have when from the IRA when you retire at age 65? So let's list all the values that we're going to need to find. A, P, R, N, T. So we know that we are depositing $100. That is going to be the P, the periodic payments that you're going to be putting in. We have the percent, the rate is going to be 9.5%, so that's 0.095. It looks like it's compounded monthly, so N is 12. How much will we have? I don't know, so we're trying to find A. And then the T is a little bit tricky because it gives you two numbers here. It gives you this 30 and it gives you the 65. So you're 30 right now. You're going to stop at age 65. To find out how many years that is, we're going to take 65 minus 30, and that gets us 35. So we're going to be depositing money in our account for 35 years. So then I'm going to go ahead and grab my formula from above. A equals P, bracket, 1 plus R over N to the NT minus 1, close your bracket, all over R over N. So when I plug my values in, I have A equals P, which is 100, bracket, parentheses, 1 plus 0.095 over n, which is 12, raised to the 12 times 35, then minus 1, close your bracket. All of this is being divided by 0.095 over 12. Okay, so the hardest thing here, I think, is plugging it in the calculator correctly, depending on which calculator you have. So if you're going to type this all in one step, you have to have extra parentheses to keep the entire numerator together and to keep the entire denominator together. So if you have one of those calculators where you can type everything in together, make sure that you put a parentheses, an extra parentheses around the bottom. You have to put that. You have to put an extra parentheses around the top as well to keep that 100 times in the numerator. And then the last thing that you'll need an extra set of parentheses on is this up here in the 12 times 35. That has to stay together before then you subtract 1. So if you have a calculator like mine, we are going to type it exactly in. Every time you see a bracket or parentheses, you're going to use a bracket or parentheses, and we'll show you how that can work. Okay, so now let's try this in our calculator. We have a parentheses. So I see a parentheses. I'm going to start with a parentheses. Then I have 100. Then I have another parentheses and another parentheses. Do you see how I'm just working left to right? If I see a parentheses, I'm going to put one in my calculator. 1 plus 0.095 divided by 12, close the parentheses. Okay, now we're going to use the exponent, so I use the caret button. Mine shows it up high, but a lot of calculators don't. I'm going to have another parentheses, 12 times 35, close that parentheses. My calculator needs me to move over and to get out, use the right arrow to get out of the exponent. Most of your calculators don't do that because they don't actually show it to you high, which is fine. Minus 1, close parentheses, close parentheses. Do you see how I opened a parentheses, closed it, and at the end I have 2 parentheses. So I'm just moving left to right, typing every parentheses that I see. Divided by, now I'm going to do the bottom, parentheses 0.095 divided by 12. Close that parentheses, now I can hit enter. So my A is going to be 333,946. So 33,946. The 295 is going to round up to a 30. So this is going to be my future value if I save for 35 years compounded monthly at a 9.5% interest rate by depositing $100 every single month. Now, in order to find the interest is going to be the value of the IRA, which in this case is your A value, minus the total deposits. So that turns into A minus P, which is the payments, times the number of payments per year times the year. So I'm going to get 333,946.30 minus $100 times 12 times a year times 35 years. So I can actually use the value that's already in there and just hit minus 100 times 12 times 35, and that's going to get me $291,946.30. So that is going to be our interest for this particular IRA.